So next we're going to look at solving right triangles. So for example 1, it says solve triangle ABC. And when it says solve a triangle, that means determine all the side lengths and all the angles. So for this example, you can start anywhere. You can solve for side B, you can solve for side A, or you can solve for this missing angle here. So first we can start with angle A. And angle A, using the 180 degree rule for a triangle, is 180 minus the sum of the other two angles, 38 plus 90. And if we evaluate for that angle, we end up with 52 degrees. Next, we pick a side. So let's say we start with side A. Well, first, let's think about what we have. Take the angle we know is 38, and we know the hypotenuse, and we want to find the adjacent side. So recall, if we're focused on angle B, or 38 degrees, that 27 is the hypotenuse, and A is adjacent angle B. So the ratio that deals with the adjacent and the hypotenuse that we're going to need is cosine. So recall that cosine of angle B is equal to the adjacent side over the hypotenuse. And in this example, our angle is 38 degrees. Our adjacent side is unknown, so we're going to call it A. And our hypotenuse, which is given, is 27 centimeters. To solve for A, I'm going to have to multiply both sides by 27 to get A by itself. A divided by 27, the inverse operation is multiply by 27. And we get that A is equal to 27 times the cosine of 38 degrees. And using our calculator, we end up with approximately 21.3 centimeters. So there is side A. So we have 21.3 centimeters. All we need now is side B. We could use Pythagorean's theorem. So if we made a mistake with side A, that'll give us an error with side B. So it's best to use what's given. So this time we want to solve for B. So we have the opposite, the hypotenuse, and this angle. So if we focus just on that. So to solve for side B, we're going to use the hypotenuse in 38 degrees. And since side B is opposite 38 degrees, we're going to need our sine ratio. So let's find side B. So side B is going to be the sine of angle B, which is our opposite over hypotenuse ratio. And so we're going to have the sine of 38 degrees is equal to B over 27. We need to multiply both sides by 27 to get B by itself. And we're left with B is equal to 27 sine of 38 degrees. We get that B is approximately equal to 16.6 centimeters. So now we have all our variables. We have angle A, it's 52, side A, which is 21.3, and side B, which is 16.6. Example 2. This is just more practice using our ratios. So solve for the indicated variable. So for example A, let's explain what we have. We're focused on angle 49. We're focused on the 49 degree angle, and relative to the 49 degree angle, x is our hypotenuse, and 121 is opposite the 49 degree angle. So we need a ratio with opposite and hypotenuse. So we're going to use our sine ratio. So the sine of 49 degrees is equal to, if we take the opposite as 121 and the hypotenuse is x. Remember, this is sine 49 over 1, and the other side is 121 over x. So the next step when x is in the denominator is to cross multiply so we can get the x into the numerator. And we have x sine of 49 degrees equals 121. And again, we only need to do this when x is in the denominator. Since we have x times sine 49, we need to divide out sine of 49 from both sides to get x by itself. And now we have that x is equal to 121 over the sine of 49 degrees. So the last part is just to use your calculator. So we see that x is approximately equal to 160 units. All right, next right triangle. This time we're looking for an angle, and we have the following two sides, and here's our angle of focus. So compared to that angle, 12 would be called our opposite side, opposite angle theta, and 13 would be our adjacent side. So the ratio that has adjacent and opposite is going to be our tan ratio. So we have that tan of theta is equal to opposite over adjacent, so 12 over 13. To undo the tan, we have to use our tan minus 1, or our inverse tan. So we're going to do tan minus 1 of 12 divided by 13. And again, this is just calculator work. So you hit your second function button, hit your tan button, which should give you tan minus 1, and then 12 divided by 13 gives us approximately 43 degrees. Next right triangle, our angle of focus is 65. We have 1.03, which is opposite 65, and we want to look for x, which is adjacent to 65. So once again, we're going to use our tan ratio. So we have tan of 65, that's our angle of focus, is equal to 1.03 divided by x. This is similar to the one we started with. To solve for x, or to get x the numerator, we're going to cross multiply. And we get that x tan of 65 is equal to 1.03. Dividing both sides by tan of 65 tells us that x is equal to 1.03 divided by tan of 65. And once again, we just need to do our calculator work. And we see that x is approximately equal to 0.48 units. All right, let's try a word problem. So Rodrigo is flying a kite and has released 25 meters of string, as shown there in the diagram. Juanita is standing 8 meters away, directly below the kite. What is the angle of elevation of the string? And this might be a new word. Angle of elevation is the angle between the horizontal line and the line of sight when looking up at an object. So here's the horizontal line, and here's the line looking up at the object. So the angle of elevation is this angle right here, theta. That's the angle we want to measure. So looking at our diagram, we have a right triangle. We have two sides with known values. They are called our hypotenuse. And the 8 meters is adjacent angle theta. So we need to use the ratio for part A that deals with adjacent and hypotenuse. So for that, we're going to use cosine. So cosine of theta is equal to our adjacent side, which is 8, and our hypotenuse, which is 25. If I want to find an angle, remember I need to take the cos inverse, or cos minus 1, of the ratio, 8 over 25 in this case, and just type that into our calculator. Using your second function button, hit your cosine button to get cos minus 1. 8 divided by 25. Make sure you have that in brackets. And you end up with an angle that is approximately 71 degrees. So let's conclude. Therefore, the angle of elevation of the string is 71 degrees. Part B. Determine the altitude of the kite. Altitude is the height of the kite from the ground. And it's the vertical distance, if you like. So we're looking for this height here. So to find this height, we need to know this side of your triangle. What is the height of this triangle? Plus, we may even need to know the height of Juanita. So the total height is the height of the triangle plus Juanita's height. So first let's start with the height of the triangle. There are two ways we can find this. The easiest way to find the height of the triangle, or this height right here, is to use Pythagorean's theorem. So if we do that, we have that 8 squared plus, if we label the height of the triangle y squared has to equal the hypotenuse, which is 25, all squared. To solve for y, that's y squared equals 25 squared minus 8 squared. Again, this is Pythagorean's theorem, just modified. And we're going to square root 25 squared minus 8 squared. And that'll give us the approximate height of the triangle in our diagram. And y is approximately equal to 23.7 meters. Now to get the altitude. So altitude is 23.7 meters plus Juanita's height. And that will give us the altitude for this kite.